All right, so here we go. This is for lecture for the 13th of April, starting chapter 5. We're going to talk about inverse functions, exponential, logarithmic functions a little bit. And we're probably going to skip one of the sections here and get into chapter 6. We'll see how things go here. So the first section talks about inverse functions. So we'll see how that goes. So the main idea of inverse functions is the x and y switch. It's really pretty simple idea. The x and y switch. So for example, I'll do a simple example here. So if I've got these points, I got those 3 points, the inverse function, let's call this f of x. The inverse function would be f inverse of x. A little minus sign up here. Switch them around. So really, when you think of it like that, it's a fairly simple idea. The points are just switched. Okay, x and y switch. X and y switch. That's what it means to have an inverse function. It doesn't mean flip it like 3/4 and 4/3. It doesn't mean that. It means the x and y values switch when you're talking about inverse functions. So number 6, I'm on page 315. Number 6 says y equals 4x minus 5. The direction says find an equation of the inverse function. Oh, just switch x and y. The y becomes x and the x becomes y. We're done. That's the equation of the inverse. Number 8, y equals 3x squared minus 5x plus 9. Switch them around. So it's x equals 3y squared minus 5y plus 9. That's it. That's all they're looking for. Number 12. Graph the equation by substitution and plotting points. Then reflect the graph across the line y equals x to obtain the graph of its inverse. So let's do number 12. Okay, now let's graph it. So if you plug 0, you get 1. We've done lots of parabolas, didn't we? It was on the last test. Plug in 1, you get 2. Plug in minus 1, you get 2. Plug in 2. 2 squared is 4 plus 1 is 5, somewhere up here. And minus 2, you also get 5. So here's a parabola. So what's the inverse of a parabola? Well, it's got to switch these points. Okay, we got to switch these points. Let's change the color. So let's change the points. 0, 1 would be 1, 0. Here's 1, 2 right here. 1, 2 would be 2, 1. So these points are all, here they are, right? So switch them points. 2, 5 would be 5, 2. Negative 2, 5 would be 5, negative 2, somewhere down here. And you'd have an equation that looks like this. So here's something about inverse functions. They're symmetric about the line, the line y. This line right here, this 45, it's y equals x. Inverse functions are always symmetric around that dotted line y equals x. Has a type of symmetry. You can see it looks pretty clear, I think. Okay, so we're going to do that for those problems. Okay. Now, the problem is with this parabola right here. The original x squared plus 1, this parabola right here. It fails the horizontal line test. So if I draw a horizontal line right across like this, dot, 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 hits it twice. That means it does not have an inverse function. It has an inverse, the red one, but not an inverse function. And that's really what we want to talk about. So for a function to have an inverse, let me write this down. So note, for a function to have an inverse, it must pass the horizontal line test. Can only hit any horizontal line can only hit once. That means it's 1, 2, 1. It has to be a 1-to-1 function. So that parabola failed. All parabolas fail because you draw a horizontal line, hits it twice. So they technically do not have inverse functions. So back up here again, the red one, it's an inverse, but it's not a function because it fails the vertical line test. It's got to pass both tests. So number 28. So here's a function right out of the book, comes down up like this, down, I think something like that, right? It comes down a little farther. Does it pass the horizontal line test? No. It's not 1-to-1, it does not have an inverse. It's really that simple. If you can find anywhere a line hitting it more than once, the answer is no. Let's look at number 36. F of x equals the absolute value of x minus 2. What do the directions say? Graph the function to determine whether it's 1-to-1. Okay, we're going to plot some points. Start with, how about a couple negative numbers, positive number, and 0. All right, so change -2, the absolute value of -2 is 2, 2 minus 2 is 0. Plug 0 in there, 0 minus 2 is -2. Plug 1 in there, 1 minus 2 is -1. We'll do maybe some more points, but let's at least start with these points. Maybe I'll just do +2. It's also 0, isn't it? So 0, you get -2. -2, you get 0. 1, you get -1. 2, you get 0. So I'm pretty sure this equation looks like this. Does it pass the horizontal line test? No, so it does not have an inverse. So you can use a graphing calculator if you want on these types of problems and see if it passes. Okay, let's jump down and do 58. Well, does this one pass 1-to-1 test? Yes. It's just a line with slope 5, right? A straight line, right? Looks like that. Yes, 1-to-1. So it does have an inverse. They want you to find it. Well, first set it to y. Now, we already learned what to do, didn't we? Switch it. Switch it. Except I want to take it a step further this time. I want you to get y by itself. Divide by 5. If we're smart, the best way to write it would be 1/5 x minus 8/5. That's your y equals mx plus b format. I think that's a little bit better. So there's the formula for it. That's F inverse. Okay. Let's try another one. How about 62? Get your graphing calculator out. Graph it. It does pass. I'm telling you right now, yes. It is 1-to-1. Put on your graphing calculator. You guys can do that. Here, I'll do a quick graph for you. Got a vertical asymptote here. I encourage you to put this on your graphing calculator. Got a horizontal asymptote. I know we did not discuss those. It does something like this, and it does something like this. Kind of screwing the equation up, but it is 1-to-1. So set it to y. This one's a little tougher. You might have to pause me a little bit and think about this. Switch x and y. Now we got to solve for y. This is going to be a tougher one. I want to cross multiply. Make it x over 1, cross multiply, cross multiply. So 5y, let's do it up here. So 5y minus 3 equals x times 2y plus 1. Distribute the x. 2xy plus x. Now we got to get the y terms together because we got to get y by itself. So these are the y terms. So subtract the 2xy over and add the 3 over. So I added just a little switcheroo. This really ain't that hard. It seemed I said a little bit harder, really ain't. Factor the y out. This is the part you better pay attention to, that step right there. Factor the y out. And then divide. So y equals x plus 3 over 5 minus 2x. So that's the inverse. X plus 3 over 5 minus 2x. So the homework for this set is starts on page 315, 5 through 10, 5 through 14, 25 through 41, 55 through 64. Okay, this is all section 5.1. All right, there's more coming here. Okay, so now we're going to do the next section, 5.2. 5.2, exponential functions. Ooh. Let's get right to an example. Let's graph 2 to the x. Not x squared. We're switching around now. X is the power. Let's just plot points. Okay, this is not as near as bad as you might anticipate. Okay, so 2 to the minus 2. Plug in minus 2 into the power. That's 1 over 2 squared, 1/4. 2 to the minus 1. Well, that's 1 over 2, 1/2. 2 to the 0. That's 1. 2 to the first. That's 2. 2 squared. That's 4. And so forth. See, pretty simple. So we plot the points. One note, all the answers are positive. Plug in minus 2, you get 1/4. Plug in minus 1, you get 1/2. 0, you get 1. 1, you get 2. 2, you get 4. 3, what do you get? 8? Something way up here, right? Here's the exponential, what they call an exponential curve. Didn't do a very good job. Boom, there it is. Exponentials grow fast. They grow tall really fast, and then they level off. They have what they call a horizontal asymptote at y equals 0. Flat line there. They go flat on the left. Okay, so see, we know that. Now shifting reflecting. Let's do y equals 2 to the x minus 1. What do you do when you replace x with x minus 1? Shift it 1 to the right. So take all these points and move them 1 over. 1 over. Should look like this. So this is y equals 2 to the x minus 1. Okay, what about the graph of y equals 2 to the x minus 3 on the outside? That's down 3. So down 3. Boom. The asymptote goes down 3. So out here, it's going to go here. Everything's going to go down 3. going to look like that. All those properties that we learned about reflecting, shifting, it all applies on this section. So look out for it, okay? How about one more here? How about y equals 2 to the negative x? Replace x with negative x. That's a reflect on the y-axis. Even though we're replacing x with negative x, it's the y-axis reflection. So this is going to go over here. This will go over here, and it's going to come down like this. Okay? All right, let's go hit the homework. All right, I'm on page 326, number 12. Nothing fancy here. Just give me a graph. Now, on the test, I'm going to want you to plot some points, not just use your calculator. I need to see how you're doing the work here. So let's plot some points. -2, -1, 0, 1, and 2. That's a pretty good base. 5 to the -2, that's 1 over 5 squared. That's 1 over 25. Pretty small number. 5 to the -1, 1/5. 5 to the 0, 1. Anything to the 0 is 1. 5 to the first, 5. 5 squared, 25. And then you can plot the points and graph it. Piece of cake. Right? I'll let you finish that one. Number 18. Y equals 3 minus 3 to the x. Okay, so now we're going to have some shifting, reflecting kind of thing going on here. So let's get 3 to the x, and then we'll figure out how to do the reflections of it. So the base curve will be 3 to the x. Okay? So let's do it manually. Plug 1 in, you get 3. 0, you get 1. -1, you get a third. So pretty much all these have this shape. So what's the minus do? That's minus on the outside. It's not a minus x. That's going to be reflect on the x-axis. The 3 is like adding 3. Up 3. Okay? So our final curve, let's make it red. Reflect on the x-axis. Can you do that? Let's take the point right here. See my pen? Let's take that point, reflect on the x-axis. It's going to go down here. Then it's going to go up 3. 1, 2, 3. It's going to land right there. Take this point up here on the right. Reflect it on the x-axis. So it's going to go all the way down here, then up 3. Take this point over here. Reflect on the x-axis, then up 3. It's going to be about here. So this graph's going to look like this. Oh, the asymptote, reflect on itself, and then up 3 is going to be here. This curve is going to come like this. It's going to look like that. Okay. Okay, now there's an important graph in here that we need to talk about. Number 18. I'm sorry, number 22. F of x equals 2 minus e to the minus x. This is the exponential curve. F of x equals e to the x. It's used a lot in science. E is approximately 2.71 something or other, like dot, dot, dot. Okay? So it's between 2 and 3. So when I graph it, we got some reflections on this one too, don't we? To worry about. The 2 is going to be up 2. I think we got both reflections this time. See the negative x and the minus on the front? Both axes reflection. Let's first do e to the x, the base curve. So e to the x, e to the x. Let's do the base curve first. Plug in -1, 0, and 1. So e to the minus 1 is 1 over e. 1 over 2.7. It's less than a half. So I'll plug in -1, you get less than a half about here. Plug in 0, you get 1. Anything to the 0 is 1. Plug in 1, you get E. 2.7 is about here. E is about here. So here's our base curve. I'm just going to make it dotted because that's not what we want. So we want reflect both axes. Okay, both axes. And then up 2. Negative x is the y-axis, and then minus is the x-axis. Let's see if we can do this. Let's see if we can do this. All right, so let's take the point right here, 0, 1. All right, everybody with me? 0, 1. Take that point. Reflect it on the x-axis down here. Reflect on the y-axis, stays home, and then up 2 comes right back on itself. Well, that's weird. Let's take 1e, this point right here, 1e. Reflect it on the x-axis. It's going to go all the way down to -e. Reflect it on the y-axis. It's going to go over to here. And it's going to go up 2. So it's going to go about here. Weird. Let's take this point, -1. This point right here, -1, 1 over e. Reflected on the x-axis comes down here. Reflected on the y-axis comes over here. Up 2 comes here. Comes about here. Yeah, I lost track now. Yeah, I think we're going to do something like this. And it looks just something like that. Let's get our graphing calculator out. We're going to verify it, okay? So 2 minus the E key is the LN key down on the left. You can find it down on the left. There it is. Yep, we did it good. It'll look like that. Okay, so practice those graphs. There's not much more to tell you. There really isn't, just the shifting and plotting points. So I'll do 11 through 14, 17, 18, 21, 22, 25, 26, 27 to 37, skip 31. This is all section 5.2, page 326. Now, the quiz. We're going to have a live class on Wednesday, and then the quiz will be 4 or 5 homework problems, a picture, send them to me. All right, I want to see how you did on that. Any 4 or 5 problems from this coming week here. All right, we'll look forward to seeing you on Wednesday for a live class.